So let's look at another example involving cylindrical coordinates. So find the mass of the ellipsoid Q given by 4x squared plus 4y squared plus z squared equals 16 lying above the xy plane. The density at a point in the solid is proportional to the distance between the point and the xy plane. So let's focus in on this information about the density function. The density is proportional to the distance between a point on the solid and the xy plane. So if I look here, let's say I have an arbitrary point on my solid here, x, y, z. Well, the distance down, you go straight vertically down to the xy plane, and that distance is given by the z coordinate. So in the end, our density function, rho theta z, it's k times z, where k is a constant. So now we need to figure out the bounds on z. So to do that, what we probably want to do is take our function here for our ellipsoid and graph it. So that's what I did right here. So let me make it a little bit bigger so we can see here. There's our ellipsoid, and we want the part lying above the xy plane. So what does that mean for our z? So let's take our equation, right, which was 4x squared plus 4y squared plus z squared equals 16, and we want to convert that to a cylindrical equation. If I factor out a 4 here, then I'll see that x squared plus y squared is r squared. So if I solve for z, and you take the square root, now here I don't need to worry about minus because I'm only looking at the part above the xy plane. So this gives me my bounds on z. Z is bounded below by the xy plane and above by this ellipsoid equation, 16 minus 4r squared. Now if we look at the projection onto the xy plane, we see that, maybe I can draw on top of this, that it's this circle here. Yep. And so if you go back to your ellipsoid equation and plug in z equals 0 into that, you'll get 4x squared plus 4y squared equals 16. X squared plus y squared equals 4. And how do we describe this circle in polar coordinates? The circle, theta goes from 0 to 2 pi. R is between 0 and 2. So now I'm ready to set up my formula to find the mass, m. We're going to integrate from 0 to 2 pi, 0 to 2, and z goes from 0 to square root of 16 minus 4r squared. And then we integrate our density function, which was kz. Remember, we get an r, because we're doing polar coordinates, dz, dr, d theta. So first we're going to integrate with respect to z. I'm going to go ahead and pull that k out because it's just a constant. If I integrate with respect to z, I'll get z squared over 2r dr d theta. And I'll go ahead and pull that 2 here out in front, so it'll be a k over 2 the square. So when I square the square root's going to go away. 16 minus 4r squared r dr d theta. You've got to distribute that r to get rid of the product before you can compute the integral. So 16r minus 4r cubed. And now integrate with respect to r. So you'll get 8r squared minus r to the 4th. So you get k over 2, the integral from 0 to 2 pi, 32 minus 16 d theta. So that'll give you a 16, which you can pull out. But because there's a 2, it'll become an 8k. Integrate, you'll get a theta. So you'll get 8k times 2 pi, or 16 pi k. And there is my mass.